Hi everyone, welcome to our YouTube channel AskPrep. In today's video we are going to study about pollution of air and water. Firstly, we are going to study about pollution of air, steps towards a cleaner and healthier future. Let's get started. Introduction. Air is a mixture of several gases, water vapor and fine dust particles. A human being respires about 22,000 times every day and takes in about 16 kilograms of air. Air contains mainly nitrogen, oxygen and smaller amounts of argon, carbon dioxide, water vapors and traces of helium, neon, krypton and xenon. Pollution is the introduction of contaminants into the natural environment that cause adverse change. Pollution can take the form of chemical substances or energy, such as noise, heat or light. Pollutants, the components of pollution, can be either foreign substances, energies, or naturally occurring contaminants. Pollution is often classified as point source or non-point source pollution. The Blacksmith Institute issues an annual list of the world's worst polluted places. In the 2007 issues, the 10 top nominees are located in Azerbaijan, China, India, Peru, Russia, Ukraine and Zambia. Significance of constitutions of air. First is nitrogen. It is an important constituent of living organisms. It cannot be utilized by living organisms in elemental form. The elemental nitrogen is converted into its usable compounds like nitrate by nitrogen fixation processes. Oxygen is extremely important for the survival of organisms as organisms respire in it. Requirement of oxygen is an essential condition for burning of a substance, hence it plays an important role in combustion. Carbon dioxide. It occurs in carbohydrates, fats, proteins, nucleic acids, enzymes and hormones. Carbon dioxide molecules reflect back the heat radiations and help the earth not to radiate heat very rapidly at night. Carbon dioxide partially dissolves in water and helps in the formation of carbonate salts. These give taste to natural water. Carbon dioxide provides oxygen to the atmosphere by photosynthesis. Water vapor rise high up into the atmosphere and get cooled to form clouds. These bring rain both on land and oceans. Snow is produced in cooler regions. The vapors control the climatic conditions. Inert gases, inert or noble gases are present in air in very small amount. These do not react with any substance but can be used in many ways. Human respiration. The air that leaves a person's lungs during exhalation contains 14% oxygen and 4.4% carbon dioxide. Atmospheres with oxygen concentrations below 19.5% can have adverse physiological effects, and atmospheres with less than 16% oxygen can become life-threatening. Layers of atmosphere. The transparent, thick and invisible envelope of air surrounding us is called atmosphere. It consists of a uniform mixture of permanent and other materials including organic and inorganic impurities such as smoke, pollen grains and dust particles. The atmosphere is divided in various layers to facilitate the study of it. Atmosphere. The Earth is surrounded by a thin layer of gas called the atmosphere. At sea level, the atmosphere provides air for breathing, wind, and weather. With increasing altitude, the atmosphere becomes thinner and gradually transitions into the near vacuum of space. The atmosphere lacks a clearly defined upper boundary. Even space shuttles orbit within its outer layers. The Earth's atmosphere contains a balanced mix of carbon dioxide and oxygen, maintained by photosynthesis and respiration. This unique combination supports life on Earth, setting it apart from other planets in the solar system. Thermosphere. Above about 450 kilometers, any gas molecules are on their way out into space, so this is called the exosphere. Below that, down to about 80 kilometers. Mesosphere. The mesosphere down to 50 kilometers is too low to be warmed by direct radiation and too thin to be warmed by convection. It includes most of the ionosphere, consisting of variable layers of atoms with one or more electrons stripped off to give them an electrical charge. Certain parts of the ionosphere can reflect shortwave radio signals and filter out X-rays from space. Stratosphere, from about 15 to 50 kilometers above us is the stratosphere. At temperatures below 0 degrees C, violent volcanic eruptions can propel gas and dust to this level, where they slowly spread around the globe. But generally, the stratosphere remains horizontally stratified, with little vertical mixing. This layer screens out most solar ultraviolet radiation. Troposphere, the bottom 15 kilometers of the atmosphere, the layer in which weather conditions occur, is the troposphere. It is warmed by radiation from the Earth and is therefore normally warmed from the bottom. The boundary with the stratosphere varies from about 10 kilometers at the poles to 20 kilometers at the equator. What is air pollution? The average person inhales about 20,000 liters of air daily, risking exposure to harmful chemicals in the atmosphere. Air pollution includes all contaminants in the air, from gases to particles, and can occur both outdoors and indoors. Pollutants inside buildings can persist, leading to long-term indoor pollution. Sources of air pollution are both natural and human-made, with human activities now responsible for most pollutants. Air pollution has been an issue throughout history. Even in ancient Rome, people complained about smoke in the air. Air pollution has numerous harmful effects on both human health and the environment. Because it can easily travel through the atmosphere, air pollution is a global issue, affecting some areas more severely, especially cities with heavy traffic or coal use. Key points: health impact. Pollutants like carbon monoxide, sulfur dioxide, and nitrogen dioxide can cause respiratory problems, including asthma and lung damage. Smog, a combination of smoke, chemicals, and fog, can trigger breathing difficulties. Environmental impact. Pollutants from industries and vehicles release sulfur dioxide and nitrogen dioxide, which can form acid rain, damaging structures like the Taj Mahal, known as marble cancer. Ozone depletion, CFCs, used in refrigerants and aerosols, deplete the ozone layer, increasing exposure to harmful UV rays. Global warming, greenhouse gases, including carbon dioxide, methane, and nitrous oxide, contribute to global warming, causing melting ice caps and rising sea levels. Industries. The WHO defines air pollution as the presence of harmful materials in the air beyond safe levels. Key pollution sources include industrial, chemical plants, refineries, and factories emit pollutants like fluorides and sulfur dioxide. Agricultural, pesticide spraying introduces pollutants such as lead and arsenic. Fuel combustion, power plants and household fuel burning release sulfur and nitrogen oxides. Metallurgical and nuclear, steel plants and nuclear activities release lead, zinc fumes, and radioactive fallout. Ore processing, crushing and grinding produce uranium and carbon monoxide. Waste recovery, recycling emits smoke, soot, and metal fumes. Natural sources like pollen and volcanic gases, as well as urban vehicles, also contribute significantly. Pollution sources can be stationary, example fuel burning, or mobile, example cars, planes, with industrial activities playing a major role in urban air pollution. Steps to prevent air pollution: use of fuels like CNG and unleaded petrol in automobiles. Switching to alternative fuels like solar energy, hydropower and wind energy, and planting trees. Traveling to school on a bicycle or on public transport or carpooling. Avoiding the burning of leaves, trash and vegetable matter. Restricting cigarette smoking. Now heading towards pollution of water, the importance of protecting our oceans. Water pollution occurs when harmful substances accumulate in water bodies, harming people, animals, or ecosystems. Although water can handle some pollution, excessive contaminants are dangerous. Extent: water covers 2/3 of Earth and 75% of the human body. Effects: toxic substances make water undrinkable and unsafe for organisms. Pollutants, sewage, silt, chemicals, and waste degrade water quality, altering smell, color, and making it unfit for consumption. Sources of water pollution: pollution enters water bodies through domestic sewage, agricultural runoff, fertilizers and pesticides, soil erosion, acid rain, and industrial waste. Rivers like the Ganga often receive garbage, idols, untreated sewage, animal carcasses, and non-biodegradable waste. Effects of water pollution: chemical contaminants, substances like arsenic, lead, and fluorides damage plants, animals, and soil by altering acidity and inhibiting growth. Aquatic life: polluted water reduces dissolved oxygen, harming aquatic organisms and reproduction. Algal blooms: excess fertilizers cause algae overgrowth. When algae die, bacteria consume oxygen, leading to further aquatic life loss. Scale and impact: pollution impact varies by quantity and water volume. Smaller water bodies like lakes or rivers are more affected than oceans. Sewage treatment: potable water, treated to remove contaminants, ensuring suitability for drinking. Wastewater treatment: sewage treatment plants purify wastewater before release, and municipal bodies treat water for household use. Causes of water pollution: oil spills, fuel oil as a water pollutant. Oil spills: spills from tankers or leaks spread quickly, making control difficult. Environmental impact: oil spills lower oxygen levels, harm marine life, and pose a fire risk since oil floats. Accidents: tanker accidents, like those in the Gulf War, cause large-scale oil spills, affecting marine life and washing oil-covered animals ashore. Land contamination: leaks from damaged pipelines contaminate soil. Bioremediation: biological processes now aid in cleaning all affected areas. Domestic sewage: domestic sewage, or household wastewater, contains organic waste and plant nutrients from soaps and detergents. Though small by weight, it's large in volume and often harbors harmful microbes, making disposal challenging. Since 1947, urban sewage in India has surged, with improper waste disposal polluting water bodies. Modern synthetic detergents with chemicals like phosphates further harm water quality and aquatic life. Next is biochemical oxygen demand, or BOD. Biochemical oxygen demand, BOD, measures the oxygen needed by microorganisms to break down organic material in sewage. Higher organic content means higher BOD, a key factor in sewage treatment design. Industrial sewage typically has a much higher BOD than domestic sewage. Dissolved oxygen is essential for water quality. Low levels, caused by microbial oxygen consumption, can harm aquatic life. Zero oxygen results in septic conditions, producing foul odors from anaerobic decomposition. Eutrophication: eutrophication occurs when freshwater is enriched with excess nutrients, often from industrial, agricultural, and urban waste, leading to overgrowth of plants and algae. This causes algal blooms that deplete oxygen upon decomposition, creating hypoxic conditions. Anaerobic organisms then produce harmful gases like methane, harming aerobic life. Eutrophication affects lakes like Lake Erie and many in India, causing odors, reduced oxygen, and aquatic life loss. Agricultural runoff: agricultural practices heavily impact groundwater quality. Intensive crop cultivation causes fertilizers, especially nitrates, and pesticides to leach into groundwater. Routine chemical use and improper waste disposal further contribute to pollution, with high nitrate levels mainly stemming from excessive fertilizer runoff from fields. Industrial effluents, industrial wastewater from manufacturing and chemical processes is a major water pollutant, with specific sectors like chemical processing and food production contributing the most toxic waste. Industrial growth in India has intensified pollution, particularly in areas under the Ganga Action Plan, where many industries, including sugar mills, distilleries, and leather units, lack proper treatment facilities. While large industries often have treatment systems, small-scale ones struggle with limited funds, worsening industrial water pollution. Effects of water pollution. Water pollution has devastating effects on humans, animals, fish, and birds. Contaminated water is unsafe for drinking, recreation, agriculture, and industry, and it diminishes the aesthetic quality of lakes and rivers. More critically, it harms aquatic life, reduces reproductive capabilities, and poses serious health risks to humans. Both individuals and communities can play a role in minimizing water pollution. Simple housekeeping and management practices can significantly reduce waste generation and help protect water quality. Water pollution statistics. The World Water Assessment Programme, WWAP, reports that 2 million tons of human waste enter water bodies daily, with 70% of untreated industrial waste coming from developing countries. In the US, agricultural runoff, especially nitrates, is a primary groundwater contaminant. Despite a DDT ban in the 1970s, its traces remain in oceans. Water pollution has left 20% of the global population without clean drinking water, affecting over 1 billion people and contributing to child mortality worldwide. Ways to prevent water pollution: 1. Proper disposal. Store and dispose of paints, oils, and cleaners responsibly. Choose non-toxic alternatives. 2. Trash and recycling. Dispose of waste correctly and recycle. Don't flush non-degradable items. 3. Avoid littering. Don't litter in water bodies. Collect and dispose of trash properly. 4. Eco-friendly products. Use natural toiletries and soap-based cleaners. 5. Limit chemicals. Prefer natural fertilizers and pesticides. Avoid overuse. 6. Vehicle maintenance. Reuse oil and fix leaks to prevent harmful fluid spills. 7. Conserve water. Turn off taps when not in use. 8. Avoid colored bathing bars. These can pollute water. 9. Reduce plastic waste. Use a reusable water bottle instead of packaged water. Water conservation. 1. Daily savings. Save water daily. 2. Mindful usage. Say only what you need. 3. Community engagement. Promote conservation in groups. 4. Involve family. Encourage water-saving ideas at home. 5. Fix leaks. Repair leaks quickly. 6. Turn off the tap. Don't run the tap unnecessarily. 7. Check toilets. Test for leaks with food coloring. 8. Reduce flushing. Use a brick to save water in toilets. 9. Wash cars wisely. Use a bucket, not a hose. 10. Reuse water. Repurpose water from washing. 11. Collect rainwater. Gather rainwater in a container. Thanks for watching. We hope you enjoy learning about the pollutions of air and water. Don't forget to like, share, and subscribe for more exciting science videos. See you next time.